Okay, good morning everyone. So, in the previous lecture, we were discussing binomial. Just one last point I actually forgot to give you. And in the same part, the binomial distribution, I want you to note down what is the mean for binomial distribution and what is the variance. So, for binomial distribution, binomial distribution mean is equal to NP and the variance is equal to NPQ. So since variance is NPQ, the standard deviation of this has to be equal to under root NPQ. And why this is important? So there can be questions like this, say example, the mean and variance of of binomial distribution are 6 and 2 respectively. Find the probability of R greater than or equal to 1. So mean is 6, variance is 2, so NP is equal to 6. NPQ is equal to 2. So now what thing, if I want to find probability of R greater than 1, probability of R greater than or equal to 1, which is 1 minus probability of R less than 1. So which is of course probability of R equal to 0. Okay, so I will have to find the probability. Probability means N C R P raised to R Q raised to N minus R. So I'll need all the things, the value of N, the value of P and value of Q. So to find those things, I will have NPQ divided by NP. This will be 2 divided by 6 is 1 by 3. NP will get cancelled out. This gives me Q is equal to 1 by 3. So since Q is 1 by 3, so P will be equal to 1 minus 1 by 3. So P will be equal to 2 by 3. So N into P is equal to 6. That is N into 2 by 3 is equal to 6. So which gives me N is equal to 9. Okay. So this will be, so probability of R greater than 1, probability of R greater than or equal to 1 is equal to 1 minus probability of R strictly less than 1, which is 1 minus probability of R equal to 0. So which is 1 minus 9C0. 2 by 3 raised to 0, 1 by 3 raised to 9 minus 0. So whatever the answer is, so 0.999. So mean and so objective questions can be asked on this, so that is why it is important. I mean, so for every distribution you will have some mean and variance. Okay, so this you have to remember for binomial distribution. Now, so I'll give you two sample space. Collection or I'll define the random variables. So a random variable.
शिटात भरतो पण मग
Random variable x is equal to say weights of 1000 people, exact weight, and the other one x is equal to the number of heads. What is the difference? Can you identify what values x can take in both of them, and what is the difference? Anyone?
Sir, in the left side, various weights will be taken, means like 50, 51, 52. So there are uh, uh, many inputs for the X.
Okay,
And
I'll
for
change
right
this a
side,
bit.
it is
Okay, Chirag, just a minute. Now I'll change my question. Heights of 1000 people. And the second one is same, x1 and x2. So what is a major difference in x1 and x2? So both are random variables. So if you could identify a major difference between both of them.
sir, in x1 it can be in decimal and
Yes.
in x2 it will be whole numbers.
Okay. So the if I am looking at the heights, okay. So x1 may take any value in certain intervals. Say for an example, so 2.5 feet to 7 feet, right? So it can take any value in this interval. And in x2, this will always belong to whole numbers, right? So very good, Xavier. So what is the difference? I mean, this x1 is called continuous random variable. Continuous random variable. Whereas x2 is called discrete random variable. Discrete random variable. So binomial distribution is of which random variable? Discrete random variable. Okay, because in binomial distribution your x is taking whole numbers, it is not taking some uh, the values of x are not in an interval. Okay, and we will be studying one probability distribution for continuous random variables. The next probability distribution that we are going to see now is the Poisson distribution. Okay, Poisson distribution. You will understand it better when we study the third distribution, why I introduced the continuous random variable and discrete random variable. Our two distributions, binomial and Poisson, both of them depend on uh, this discrete random variable, which means that your uh, random variable is going to take discrete values. It won't take what you can say continuous values. I mean in some interval. Okay, fine. So what is Poisson distribution? In Poisson distribution, probability of x is equal to r success is given by e to the power minus z into z raised to r upon r factorial, where z is equal to mean, which is also equal to np. Again, your data follows Poisson distribution, and data follows Poisson distribution if number of trials is large and probability of success is very small. Look, we started binomial distribution where we said that there are only two choices: either there is success and there is failure. So Poisson distribution is also for the same case where you have only two choices: success and failure. But it may happen that now which is better. Okay. So how do we decide which distribution is better for my data? Okay, and we decide it by looking at the number of trials, the value of n, and the probability of success. So if the number of trials is small, then the and probability of success is I mean not very much small, then we can go for binomial. If the number of trials is very large and probability of success is very small, so in that case the data will follow the Poisson distribution. Fine. So mean is this, and with that I will also write down the variance. Why this has happened? What was the variance in binomial distribution? Okay, anyways, let's not get into those limit and continuity details. Uh, in Poisson distribution, mean and variance, both of them are z. So that's it. The definition of the Poisson distribution. In Poisson distribution, probability of r successes is given by e to the power minus z into z raised to r upon r factorial, where what is z? Z is the mean. Okay, if the mean is not given, then Z can also be found out by this formula, N into P. Fine. Let's get to the example. A manufacturer of quarter pins knows that 2% of his product is defective. Of his product is defective. If he sells quarter pins in boxes of 100 pins and guarantees that not more than 5 not more than 5 pins will be defective. Find the approximate probability. Find the approximate probability that a box fails to meet the guaranteed quality. So what is the number of trials in this case? Out of how many things the probability is given to you? So in a box there are 100 pins, and a pin will be, 2% of his product is defective. So number of trials is 100. Probability of success, what is your success? Being pin being defective is my success. So probability of success is 2%, which is 2 by 100, which is 0.02. Okay, and he guarantees that not more than 5 pins will be defective. Okay, so find the approximate probability that a box fails to meet the guaranteed quality. If a box wants to fail the guaranteed quality, it means it must have more than 5 pins defective, right? So first of all, number of trials is very large and probability of success is very small. So that's why this will follow the Poisson distribution. In Poisson distribution, the value of Z is N into P. So let me just write it down in detail. Z is equal to N into P, which is 100 into 0.02. So which is 2. The value of Z is 2. What is to find? Probability of R greater than 5. Yes. So probability of R is given by e to the power minus z. The value of z is 2 in this case. E to the power minus 2, 2 raised to r upon hello.
Yes, sir.
Yeah. So we are at finding the probability. Probability of r greater than 5. So this will be given by total probability is always 1. So 1 minus probability of r less than or equal to 5. So this is 1 minus probability of r equal to 0, r equal to 1, r equal to 2, plus probability of r equal to 3, plus probability of r equal to 4, plus probability of r equal to 5. So what we can enter in our calc is 1 minus summation e to the power minus 2, 2 raised to x upon x factorial. X is running from 0 to 5. So in this e to the power minus 2 is a constant. So constant I can always take outside the summation. E to the power minus 2 summation 2 raised to x upon x factorial. X is running from 0 to 5. So this will be easier for you to enter in your calc. Please try to enter the summation in your calc and tell me the final answer.
Sir, 0.0165.
Yes. Anyone who is not getting how to enter that summation thing in your calc? If you have your calc, please try it. Okay, so everyone is getting it. So the answer for this is 0.0165. So this is the probability that a box will not meet the guaranteed quality. Okay, fine. So let's go to the next example. Number of road accidents number of road accidents on a highway during a month follow Poisson distribution. With mean 5. Find the probability that find the probability that in a certain month number of accidents on the highway, number of accidents on the highway will be, first one, less than 3, second one, between 3 and 5, third one, more than 3. What is given to us in this case? Mean is given to us. Okay, so what is the value that is given to us? Which value is given? They are saying that your number of road accidents on a highway follows the Poisson distribution,
N into
and
P is
Z is equal to NP, which is given to be 5. So the value of Z is given to us. So probability of X is equal to R successes will be e to the power minus 5 into 5 raised to R upon R factorial. Okay, the first thing that we are supposed to find, probability of R less than 3, which is equal to probability of R equal to 0 plus probability of R equal to 1 plus probability of R equal to 2. So this is e to the power minus 5 summation 5 raised to R by R factorial. R is running from 0 to 2. Let's do the calculation. Everyone, please try this. If you don't try this right now, you won't be able to do it in the final exam. Yes, Atharva, Ish Patel, Chirag, what is the answer?
So it is coming large.
Sum is large.
Uh,
No, that is not
yes.
possible. Yes, Aryan. Janvi, what is the answer? Xavier,
So I'm calculating.
Shikhar.
Sir, it's point 1246.
Yes, is correct. Look, if you are not able to do that summation thing, you just find it for each and every one. So you can enter the function e to the power minus 5, 5 raised to r by r factorial. And then just like we did for the tables, calculate. And you put the value of r equal to 0. So you should get 0.006738. Then again press equal to, you will have to enter the second value 1, so 0.033690. Then again press equal to and give the last value of r equal to 2, so that will 0.084224. And if you add these things, so the final answer is what Shikhar said, 0.1246.
Sir, getting it now. 0.1.
Fine. The second one, between, there is a bit of ambiguity in this. They must have specified if 3 is included or not. So we'll consider it to be included. Probability of 3 less than or equal to r less than or equal to 5. So this is probability of r equal to 3 plus probability of r equal to 4 plus probability of r equal to 5. E to the power minus 5 summation 5 raised to r by r factorial. R is running from 3 to 5. And the answer for this is
0.491.
0.4913. Third one, probability of r greater than 3, which is 1 minus probability of r less than or equal to 3. So 1 minus e to the power minus 5 summation 5 raised to r by r factorial. R is running from 0 to 3.
So 0.7349. 7.
0.73. Okay. The average number of misprints per page of a book is 1.5. Assuming the distribution of the number of misprints follow follow Poisson. Find probability that a particular page, a particular that a particular book is free from misprints. And the second one, number of pages with more than one misprint. If the book contains 900 pages. Yes, please do it. So what you are calculating, you will be probably finding the probability for one page, and what you are asked in the second one, in how many pages and how many pages will you have more than one misprint. So you will have to find the probability that you will have more than one misprint in a page, and then you will have to multiply it by the number of pages. No misprints, you will have to find the probability for r equal to 0. Is it that difficult? R equal to 0, that will be e to the power minus z. The value of z is 1.5 into
Sir, it is
1.5,
coming 0.2231.
0.2231 exactly. For the second one, more than one misprint, so probability of r greater than 1. So which is 1 minus probability of r less than or equal to 1. So which is 1 minus in bracket 0.2231 plus e to the power minus 1.5, 1.5 raised to 1 upon 1 factorial.
Sir, 0.442.
0.44
442.
4421. So this is the probability that on a single page you will get more than one misprint. Probability of getting more than one misprint. More than one misprint on one page. So out of 900 pages, that will be 0.4421 into 900. So that is approximately
398.
398 pages will have more than one misprint. Fine. So that is all about the Poisson distribution. I'll just discuss one example. Of course, I'm not going to take it. I'll just discuss. The below data that I'm going to write is accidents per shift in a factory. So accidents per shift. So by that, so if 0 accidents, 1, 2, 3, 4, 5 frequencies, 142, 158, 67, 27 and 51. So now suppose there is a factory and in that accidents X per shift. Okay, so per shift there are 0 accident, so the frequency of it is in a certain time period. So 142 shifts are there in which there were no accidents. So 158 shifts were there in which you got one accident. 67 shifts in which you got two accidents. 27 you got three. This is all the data that I have. Now this is the actual frequency. Okay, and what I want to do is I want to find K for 6. Okay, so there will be 6 accidents and in how many shifts this can happen. Okay, that is to be estimated. I don't know actual data, but I want to actually get some idea in how many shifts there may be 6 accidents. Okay, and how can I do that? So I will fit the Poisson distribution to this. How do I fit Poisson distribution? Is by doing this. So I will assume that suppose this follows the Poisson distribution, and what will happen is I can find the mean for this data. So you have x, you have the frequencies, so summation x into f upon summation f. So I will get the value mean, which is the value of z. Then what I can do is probability of x is equal to r is equal to e to the power minus z, z raised to r upon r factorial, right? So this is the formula for me. So what I want to find for 6, I mean in how many shifts I will get 6 accidents. So what I will have to do on the right hand side, e to the power minus z, z raised to 6 upon 6 factorial, right? And I will get some answer. Now say I have got say 0.00151. Okay, do I have total shifts? Total number of shifts? Yes, can anyone give me total number of shifts from the above data?
We have to add the.
You just have to add the frequencies. Okay, so if we add the frequencies, so that is 142, 158, so that is 267, 20. So that is 400.
400.
So 400 into 0.00151. So you will get approximate number of shifts. Okay, so this is how probability plays a major role when you want to estimate things. So that is almost 0.604, so one shift. So the answer is 0.604, which is nearly maximum in one shift. You may get 6, or it is not possible. Okay. Anyway, this kind of example is, I mean, excluded actually, but this gives a idea why we are doing this distribution. Fine. If you have any difficulties in Poisson distribution, please let me know, or else we'll stop here.